All right, this is 4-1, solving a system of equations by graphing. A system is more than one, so I'm going to give you two equations, or sometimes three, but I'm going to ask you to solve the system. And the first way to do this is by graphing. Graphing is just one of the methods to solve a system. And so what we're going to do is we're going to graph the lines and then basically find the point of intersection, the point where they cross at. So let's look at this red line. The red line is in y equals mx plus b, and I'm assuming you remember how to graph using y equals mx plus b. Your y-intercept is -4, and then your slope is down 2 over 1, down 2 over 1, down 2 over 1. And I want to emphasize to you to put as many points as you possibly can. The more points you put, the longer your line will be, and the more accurate your line will be as well. And then I also suggest that you use a straight edge. In the past, if you have a very steady hand, it was okay. But here you really need to be accurate on the line because you need to find the point of intersection. So if your line is just a little bit off, it's going to throw off the final answer. And so that's the red one. And now let's look at the blue one. We have the y-intercept starting at +6, and then we're going to go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. And then the same thing, you want to make this as long as possible and then accurate as well. And then you're going to, again, use a straight edge to connect them. And what I'm interested in finding is the point of intersection. The point of intersection is -4, 4. So this is my answer. That is the answer, the solution to that system of equations. Now, there's a couple ways to check this. This is your x, y. So if I say -4, 4 is my answer, that means if I substitute -4 into my x, so if I substitute -4 right here, then I should get +4 for my y. And then you should be able to check it out to see if it does. Well, the same thing here. If I put -4 right there for my x, and I put 4 here for my y, then the left side should equal the right side. And you can easily see that it does work. So that's one way to check it. This point has to work for this equation, and it has to work for that equation. So again, if you substitute that point in, then it will work into both equations. Another way to do this is on your calculator. So if I substituted or type these equations in, -2x minus 4, and then 1/2 x plus 6. One way to do it is just simply graph it, and that confirms the same graph I have. Another way you can do it is go to the table, and if you look at -4, because I think the answer is -4, 4. Well, notice you have -4, and then the y columns are matching. And so that means that that is the common point between those two lines. So I verified how to do this, and that's one way to do it. The other way you could do it, there's actually a cool feature on your graphing calculator. If you go to second trace, you have the calculate option to come up, and you want to find the point of intersection, which is choice 5. You're trying to find the point of intersection. And so what you're going to do, you're going to move the cursor over to where you think it's going to cross at. And you get as close as you can to the point of intersection, and then you're going to press the enter button 3 times. And notice it tells you the point of intersection is -4, 4. So there's several ways you can check your answer by doing this. Let's look at another illustration. So here I have the blue line and the red line again. And so if I graph the red line, I'm going to go ahead and put this in y equals mx plus b. And so I have y equals -2x plus 8. So if I graph that, that's -2x plus 8. I'm going to start at +8. I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. And again, at several points, the more points you put, the more accurate it's going to be. And so I'm going to go ahead and graph that red line. All right, and then the blue line, I want you to notice something as well. It's starting at positive, or starts at -1, and it's going to go down 2/1, down 2/1. And then you're going to grab your ruler as well. And then you're going to connect the dots on this one. But I want you to notice something as well. Did you notice, I mean, they look parallel, but did you notice something before we even graph? Did you notice that the slopes are the same? And remember what we learned in the last chapter, parallel lines have the same slope. So I noticed that these have the same slope, they're both parallel. These lines will never, ever cross. And remember, I'm trying to find the point of intersection. Well, there is no point of intersection on parallel lines. So you just literally say there is no answer, or there is no point of intersection. So if you happen to notice that the lines are parallel, you don't really have to do anything else. You automatically know that there is no answer. There is no point of intersection with parallel lines. So there's another scenario like here. If I started graphing the red and started graphing the blue, something else is going to happen. So if I solve for y equals mx plus b, you're going to see something. So you're going to get y equals 3/4 x plus 2. Well, I want you to notice something. That's the same equation as the blue equation. So if I graph this, you know, if you literally started graphing, start at plus 2 and then go up 3/4, go up 3/4, and you graph this line, and then you went back and you graphed the blue line, then you try to find out how many, the point of intersection. Well, the point of intersection on this is actually every single point, because every single line is going to be in common with that. So the blue line and the red line have every single point in common. I actually graphed that wrong. So that should be going there through there. So this line is actually a little bit off. So let me back that up because I did my slope wrong. That's a good way to check. That's why we use rulers, so you can definitely check it. Okay, so up 3, 1, 2, 3, 1, 2, 3, 4 over, and then 1, 2, 3, 1, 2, 3, 4 over. And then if you grab your ruler, they're gonna match up. Again, it's a good reason why we use rulers to make sure they all line up perfectly. Right. But anyway, my point what I was going to say is, if I graph the blue one would be literally, it would literally cross at the exact same point here, there. Every single point on that line is the blue line and the red line. So here, if I ask you for the point of the point of intersection, you would just say all solutions, or every point, because every single point of the red line is every single point of the blue line, because it's the exact same scenario. So you have 3 possible scenarios. When you graph lines, they could cross at one point, just like this. They cross at one point, and if they, one way to easily tell that is if the lines have different slopes, then they will cross at one point. This one is the one I just got done doing, is like, what if, the blue line and the red line happen to be the exact same equation, then it's all solutions. All solutions will be every single answer that's common with the blue is also common with the red. And then what if there's parallel lines? So, if you have the same slope, because same slope, parallel lines have the same slope, then there's no answer in common. So that's the third example that there's no answer in common. So there's three possible scenarios. If I ask you to solve a system of equations, it's one of these three scenarios. So again, let's look at this one right here. You have two graphs, and we could graph on a piece of paper to do this, but this one I'm going to actually show you the calculator. I want to show you something very unique on the calculator. I showed it to you on the first problem. So if I type this in, 2x minus 3, and then I'm going to type the blue one in as negative 5x plus 6. Well, if I graph this, notice the point of intersection. Now, the point of intersection, I want you to be very, very accurate on this. I want you to be accurate to the 1,000th place. In other words, the third decimal place. Now, it looks like, if you look at where it crosses at, it looks like it's over 1.2 or something like that. I want to find the exact point of intersection, like literally find it and see where it's at. Now, if you want to zoom in, you could go to zoom, enter in, move your cursor over to the point of where you want to zoom in at, and then I'm going to press enter and zoom in right there. So the point of intersection, if you just kind of just move the cursor over, it sort of tells you where the approximate place of intersection is. But the way to actually do this, again, I showed you this on the first illustration. On your calculator, push second trace, and again, find the point of intersection is choice 5. And then what you're going to do is move the cursor, see the cursor moves over, and move it to the point of intersection, which is right there. And then basically hit enter 3 times. Make sure you hit enter 3 times. Enter, enter, enter. And then it tells you the point of intersection. And remember, I want it to the 1,000th place. So 3 decimal places. So the x is 1.286, and the y is negative 0.429. So that's how accurate I want you to be. That is the point of intersection. And there is a way to do this without the calculator, but we just haven't learned that method yet. So for right now, you have to use the calculator and find the point of intersection. And again, I want it to the 1,000th place. And there is a way, I did show you, remember, if you wanted to if you wanted to change float, if you have a problem with rounding, you can simply just change the float to float 3. And then if you go back and then do the point of intersection again, enter, enter, enter. And notice it rounds it for us. See, so if you have a problem with rounding, you can easily just go to float and then float 3, because we want 3 decimal places here. So that's how you would do that. And that's how you would graph solve a system of equations by graphing and even using our calculator, the point of intersection to check.